Hi, my name is Daniel Odamelum, and this is Project 2.1, Digital to Analog Conversion, the R2R resistor ladder. Also known as the R2R DAC, this 8-bit DAC converts a digital binary signal into a corresponding analog voltage, relying on Thevenin's equivalent circuit theorem and the superposition principle for its operation. This circuit has two resistor values, R and 2R. There are 8 digital inputs in the circuit ranging from B0 to B7, which represent the Arabic numbers 0 through 255 in binary. First, let's talk about Thevenin equivalent circuit theorem. Thevenin states that any linear circuit, no matter how complex, can be simplified to an equivalent circuit consisting of a single voltage source with a series resistance and ground. So basically, Thevenin says that we can take any linear circuit, in this case the R2R DAC, and reduce it to just a single voltage source, single series resistor, and ground, called the Thevenin equivalent. In the R2R ladder, each branch is connected to a bit that can be replaced with a simple Thevenin voltage source and resistance. This makes it much easier to analyze each bit's contribution to the total output voltage. So here we have 2R and 2R, which are both resistors in parallel, and according to Thevenin's equivalent theorem, these two cancel out and become R since they are in parallel. Next we have R and R, since this is now has a resistance of R. R and R in series now have a combined resistance of 2R. So now that we have 2R here, we have 2R in parallel, puts R on this junction, and the pattern continues all the way down till you get resistance of voltage out is just R. This is where the second principle, the superposition principle, comes in. The R2R DAC has multiple inputs, each representing a bit in the binary number system. The superposition principle says that the total output can be found by looking at the effect of each bit one at a time. For example, if we want to know the third most significant bit and how it affects the voltage output, we treat it as the only active source, shorting out every other bit input, considering them as 0. We then calculate the output voltage based on this single input. Based on Thevenin's equivalent theorem, we know that this will be 2R, this will be 2R, this here will be half of that due to them being in parallel. And we repeat this process 2 more times to get the voltage contribution of bit 5 is the total input over 8. By repeating this process for every other bit from bit 0 through bit 7, we get, when assuming a 9-volt power source, the maximum voltage output we can get when turning on every bit would be 9 times 255 over 256. Meaning we get 9 times 255 over 256 volts as our total voltage output. The last thing that the superposition principle states is that if you want to find the voltage contribution across multiple bits, the bits can be summed. So if I want to find the voltage contribution across bits 3 and bits 5, I add the 2. So bit 3 has a contribution of 315 millivolts, bit 5 has a contribution of 1.2 volts, and when you add the two together, you get the rough contribution of 1.48 volts. The last component of the R2R DAC that's important is the LM741 op-amp, which acts as a voltage follower. This is important for stabilizing the output voltage. The way it's wired, the op-amp has unity gain, which means the output voltage is the exact same as the input voltage. What makes it useful is its ability to buffer the circuit. Without a voltage follower, the output of the R2R ladder might be affected by the load that it is connected to, and any device that draws current from the DAC could cause voltage drop, making Vout unstable. The voltage follower prevents this by providing a very low output impedance, meaning it can supply enough current to drive a load without causing the voltage to drop. It effectively isolates the R2R ladder from the load, ensuring that the calculated analog voltage remains accurate and stable no matter the load that is connected. My name is Daniel Odamelum. Thank you for listening.